Hello, everyone. Thank you for taking the time today to attend this half-hour session as a part of our virtual events week, Unlock AM Live, the digital post-printing experience. Today's topic will be Connecting the Future of AM, a live digital thread demo. Your presenters for today are Andy Cottage, Director of Customer Success, and Nick Cazzillo, Senior Applications Engineer. This is an interactive webinar with polling, a live demo, and an opportunity to submit questions at the end of the session through the chat feature. All participants will be muted throughout. Additionally, the session will be recorded and made available for download afterwards. Finally, if you hear anything during the webinar that you might want to talk about more in depth, remember that we're offering one-on-one coffee chats with our experts across North America and Europe for the remainder of this week. If you're particularly interested in seeing our solutions in action, we have a number of time slots available for live solution experience tours, during which Nick or our technical trainer, Francesca, will be guiding you through automated post-printing in real time. Head over to our main event site to sign up for one of those sessions. All right, now that I've kicked things off, I'll hand it over to Andy. Andy, take it away.
All right, thanks, Diana. So I just want to give you a brief overview of what we'll be covering in the next 30 minutes. So we're going to start off by talking about today's digital thread reality and some of the challenges that it causes when that digital thread is broken. And then, of course, we'll talk about the opportunity for connecting that digital thread and what we're doing here at PostProcess Technologies to connect that. And then we want to spend at least half the time going through a live demo of our connected platform that's in its beta version right now, and give you some insight into what that looks like and some of the capabilities. And then we're going to go live to the lab with Nick, who's with one of our solutions, our Demi, where he'll be able to show you how the connected platform connects with those machines in the lab. And then we'll leave some time at the end for a quick wrap up and 5 minutes or so for Q&A. So before we kick off the content, we'll have a polling question here. So when a lot of people think about automation, they think about scaling and production level volumes. So we wanted to ask, what is the current scale of your additive operation? So many people at varying different levels, and many have aspirations to scale their volume. And but we're trying to get an understanding of the audience today and where you're currently at. So we'll just give you a few moments here to respond, and then we'll take a look at the results.
Okay, what we're seeing is about 60% are at the R&D phase right now, 20% at mass customization or production levels.
Great, great. And you know, I think a lot of people that are in the R&D phase do have goals to continue to scale up. But we'll talk about some of the advantages of the connected platform, even in an R&D phase or a high mix, low volume environment, and some benefits that can provide. So what you see on your screen here now is just a very simple depiction of the digital thread that we're experiencing today that many of you are aware of. And the design phase, the print phase are clearly very heavily data driven and software driven. And oftentimes the third step, manual post-printing, is taking place. So a lot of you might be familiar with these struggles, limiting your scalability, your quality, the sustainability of the operation overall. So limiting your output of additive manufactured parts, your failure rate may be increasing or something that you're trying to get better control of. And ultimately, you're relying on tribal knowledge, really in the design and print stages as well, but most certainly the post-printing stage. So ultimately, it's going to limit your manufacturing flexibility and really just limit your overall surface capabilities. So this became really apparent to us a couple years back when we visited a customer, and here's a snapshot of them. And of course, we're joking, but many people might say that this isn't too far off if you look into the corner of their lab where post-printing is taking place. There may be a lot of hands-on activity, a bit of a pile-up or a bottleneck, if you will, and it becomes a bit of an art for someone to now take what's come off a printer and turn it into a finished product. And of course, all of that data, all of that information that went into the process up front is pretty much not being used at all at this point. It's really a matter of relying on tribal knowledge and a lot of hands-on effort to deliver a final product. So I think we're all trying to evolve beyond that and curious what the opportunities are to do so. So what we're looking at here on this slide is a couple of screenshots of the connected platform that you'll get some insight into in a few moments here. But really, we're talking about that end-to-end automation and really that closed loop intelligence as you see on your screen there. And really that the emphasis of this digital thread is to revolutionize manufacturing. And really this idea is that all things related to part design through manufacturing and into end use is represented by digital information that effectively represents the construction of a part. You may be familiar with that digital twin model. So this makes the process and part smart, as all the information associated with the part is not only captured in the design stage, but more importantly now, it describes how the part will look and be manufactured. So the direct digital thread, or what we call DDT, which is actually a file name that we use when sending information, works by connecting each of those stages in the additive manufacturing process to ultimately create a file that not only contains the parametric design of a part, but also the associated data which goes into that part, such as print parameters or post-printing parameters. And on the printer side, you might be thinking print speed, extrusion temperature, support material design, part orientation on the build plate, and so forth. Then, of course, for us, we're constantly thinking about the post-printing parameters such as temperature, maybe it's a media or chemical formulation, different agitation levels or fluid flows. So integrating those all into a cohesive manner. So you take and you look at these from really the three pillars at which we approach many of our problems through an automated and intelligent and comprehensive approach. When you think about automated, really taking that digital digitization of tribal knowledge and taking advantage of that, so you're no longer relying on someone's memory bank for a successful outcome. And then when you look at from an intelligence side, a really key phrase that I want to take away from today's presentation is the idea of being more predictive, the idea of being proactive, and starting to leverage this information through autonomous machine learning. And ultimately having increased output of the additive manufactured parts with that quality that you expect each and every time. So you're thinking really flexibility in your workflow, being able to enhance your service offerings and truly leverage that power of data. So some things that might come to mind is the idea of pull manufacturing, where you're responding more efficiently without taking on wasteful activities or dealing with those extra bottlenecks. Or the idea of asset traps, where you might be purchasing additional capital equipment for small projects or unique features that you have to try to take on, and that's requiring you to acquire more assets, which may be limiting your future capabilities. And what the data also gives you is some visibility and transparency into how you're truly performing, what are your capabilities, and what are your areas for opportunity. Again, collecting this data is really important to allow for continuous improvement. And then ultimately being able to address, again, those production needs. It could be that high volume, low mix that I spoke about a moment ago, and that could be more in the R&D phase or customization phase, and ultimately allow for high volume altogether as well. And then truly, again, leveraging these manufacturing networks so they can continue to learn and optimize eventually on their own, and you're connecting to networks beyond even additive manufacturing, the other areas of your facility that may can learn from this information as well, and ultimately simulate and replicate using all these elements to be more efficient as your operation scales. So what we want to show on this next slide here is a bit of that workflow that I'm sure you're all familiar with, the design and print side. And we want to expose a little bit more about the post-print side. And again, specifically today, we're going to get into connected. So we're all familiar with when you create a design in CAD, it goes into a slice geometry where a lot of information is packed in there for the printer. And of course, the design team can learn from that. They can understand some of those outcomes. So that's a nice closed loop system. And we're trying to create the same thing on the post-print side. And today you may be familiar that we have an automated platform that exists on many of our solutions where we're monitoring data real time. You're able to have maintenance timers, alarms, and warnings that can keep your process in control and let you know if anything is out of the ordinary. But you can see what we're introducing here is connected. And I won't run through this complete list, but some of the key elements here are really being able to have remote control and visibility over your solutions. So if an engineer is in their office and wants to see what's going on in their manufacturing floor, how the workflow is operating, and if there's any sort of machine parameters that are out of control, you have visibility into that. And then ultimately, the key piece we want to hone in on here is this idea of recipe generation. So that's really closing that gap of reducing tribal knowledge and leveraging data. So we want to be able to take those parameters and generate post-print parameters to be able to run an effective, repeatable cycle each and every time. So before we get into that, we have one more polling question for you. And the question here is, when? So when do you foresee the digital thread and automation becoming commonplace in post-printing operations? So for many people, they've probably been yearning for this for a while, those that were early adopters. And then some other people, this may seem very far out. This may seem like a very far reach to start thinking in this manner. So we're interested in understanding, when do you foresee automation becoming the norm, especially on the post-printing side? So I'll give you a few moments here to respond.
Yeah, Andy, it looks like the majority of 57% within 1 to 5 years. And then the next largest bucket is 29% at 5 to 10 years.
Great. Yeah. So so a lot of people are definitely asking for this. They see the benefit of it, and they want to see it sooner rather than later. So that's a great sign. And that's a perfect segue into our live demo of Connected. So what we're going to do here is I'm going to slide our Connected platform onto the screen, and I'm going to walk through what you're taking a look at. So what you see on our screen here, we have 4 main modules within the Connected platform. We're going to spend the majority of the time on the first 2. The first one here is really the viewer, or the builder, we'll call it, because you can view your parts within your actual machine. And what you're looking at here is the DEMI, which is the same machine you'll see when we go live to the lab. And what you're able to actually do, if you have multiple solutions, you can change and select those different working envelopes, and you can start to get an idea of your batch size. So I'll go back to the DEMI because that's the one we're working with today. And if I was going to pull in a test part, you could start to get an idea of how much space that actually takes up in your chamber. And I could keep doing that and move these around, and you'll start to see some different visuals on the screen that might indicate if you're starting to overfill or going outside the boundaries here. So that's one portion of the builder. And on the other side, we have that recipe generation. So there's 2 different ways that you can generate a recipe. The first one is by manual introduction of parameters. So I can go through this series of selecting different print part parameters. So here I selected polyjet. It gives me an option of different materials that I could select from. And then I can continue to go through the flow here, select the build and support material, and then the build thickness, which we've tried to boil down into robust or delicate. And there's some math that goes into each one of those that we could educate on. But to keep it simple, we've tried to have just a couple drop downs there. And you'll see immediately, once those are filled out, technology pops up that says there's a couple different ways you can solve this problem. So there's 2 different technologies where we can address polyjet support removal. One is our SVC, which is in line with our DEMI technology, but we also have a spray technology, or BVD, that this can be solved in. And you can see a couple different cycle times here. And another metric that we're continuing to hone in is the sustainability. Sustainability is important to us as an organization. We're thinking about chemical recyclability, energy usage, overall cycle time and throughput, trying to, of course, minimize cycle time, maximize throughput to ensure you're getting the most value for each and every processing cycle. So you can see here, the recipe's been generated, but I could also introduce, in this instance, a CMB file. So a sliced file I can import, and that also kicks out a recipe. So you can see you have some different results, cycle times, and sustainability measurements. But ultimately, it's letting you know that you have a couple options. And of course, we want to use, again, the demi today. So I'll click on this, and I will go ahead and name this whatever I would like. You can name it your part name, whatever makes sense for your facility. You see the parameters down here, and then I'm going to click send. So it's going to say that it was sent successfully. So now what I'm able to do is go over to the dashboard. So within the dashboard, you're going to be getting real-time information. You can see some sensor data, temperature, pressure, tank level, ultrasonics feedback. So you're able to get all this real time. And what you'll also see is you have the ability to have some remote control here. And when we go into the lab, Nick will demonstrate some safety features to make sure that someone in an office somewhere is not overriding someone in the lab and vice versa. But ultimately, at the bottom here, I'm able to click on our connected or C3D database, and I should see the recipe that I created, and that's listed here. And ultimately, I have the ability to start that recipe right from my seat here. So what I'm going to do is I'm going to press play, and then I'm going to get set up and pass it over to Nick to demonstrate to you how this is functioning in our lab.
Hello, everyone. Nick here, lab in Buffalo, New York. Welcome. Just a quick orientation. Right behind me is the demi that Andy set up from his office. And you'll be able to see the screen or the software mirrored on the top right-hand portion of your screen. Down below that is Andy's connected software that I'm also team viewered in on, so you can see both happening simultaneously. So Andy set up a recipe for me that's currently running. You might be able to hear it in the background. And you can, of course, see it in the TeamViewer application there. For safety purposes, the individual in the lab always has override power. So I can go ahead and pause or stop this cycle that Andy started entirely. So let's say, the workflow manager or the part designer, he's loaded up the build envelope in his printer. He's also loaded up the envelope and connected for post-printing. I'm the technician in the lab here. I have the parts off the printer. I can go ahead and place it in the machine. And as you saw Andy start the cycle remotely, I also have the option here in the lab to start it in real time. So you can see on the TeamViewer application, the May 20th, 2020 connected 3D is already loaded. If it doesn't happen to be loaded, I can also access it in my recipe folder. So I have my user-defined recipes here. I'm going to navigate over to connected, and I can recall that May 20th recipe. And it eliminates all the guesswork. I don't have to rely on, tribal knowledge to figure out which parameters are going to work best. You loaded that CMB file. It selects the right temperature. It knows the proper cycle time to achieve a clean part. All I have to do is load that part in and go ahead and hit start. And you'll be able to see the process occurring in that TeamViewer application, as well as the real-time outputs and connected if you happen to be monitoring from a remote office or somewhere else in your office building. Up top, you can see a few different parameters that are monitored on the automated software, like pressure, ultrasonic output, and temperature. And you can also see that in the connected application, as well as some maintenance information. All right, so with that, I'll hand it back to you, Andy.
All right, thanks, Nick.
Of course.
So as my screen is loading up here, there we go. Just want to talk about a few key takeaways here at a high level, just the understanding, and based on some of your poll responses, I think we're all on the same page that really collecting and connecting data throughout the entire workflow is really imperative to fully leverage additive manufacturing, excuse me. So some of the big whys behind this, I think we all think about increased output of our additive manufactured parts. We want to be able to truly leverage the power of those printers. And we want to reduce the failures or the quality defects that we see, especially in the post-printing stage. Reduce those reprint numbers and get it right the first time. And ultimately, we demonstrated through generating a recipe through data, you can start to remove some of that knowledge bottleneck. So both in design and printing stages, you can leverage this data, but we're emphasizing here the post-printing side, which is truly a work of art these days for many people. And ultimately, for the sustainability of your organization, really the flexibility it can provide and overall improve those surface capabilities as you become streamlined, leveraging this information at your fingertips. So we definitely have time for Q&A here.
Yep. So we'll open the chat back up and you'll be able to submit questions through there. So we'll just give it a moment for you to get your questions in. Okay, the first one I'm seeing here is, what file types is this digital thread software able to take in?
So right now, today, we demonstrated the CMB. So that's the first one that we've been working on most closely with. But this is something that we can set up a separate chat with to understand your particular needs, as all those file types contain different information. So that's something that we can better understand in more of a one-on-one conversation.
Okay. How would this software work with other additive workflow platforms?
Yeah, that's a good question. So we've set this up to have API functionality. So we do anticipate that being the case. We don't have anything today that we're connecting to directly, but we do have that built into the back end to be able to prepare for when that day comes.
Okay, great. Next question is, when will this be available to users?
Sure. So right now we are shooting for the end of the year as a commercial release, but prior to that, we're considering beta users as early as Q3. So you're looking at a couple months now. So if you are interested in that, definitely reach out to us and let us know what your situation is, and you may be a good fit as a beta user for Connected.
Great, thanks. Okay, another question coming through here. Is this a desktop or cloud software?
So all the data is kept in the cloud, but this is actually today ran as a desktop native app. But the future goal is to have it be a cloud-based software.
Okay. Being asked about where our distributors are. So right now we are available in North America, Europe, and Japan. Okay, this question is, what is the most complicated internal passage configuration that you have worked on?
Sure. So it really depends on technology, print technology, and need. So what I mean by that is PolyJet is going to be different than SLA or DLP resin removal. So you can see on our website we have some pretty complex medical applications, heart models, so to speak, and some different SLA geometries with some rather long and tight internal channels. So if you provide us with some more information on what your particular challenge is, we can take a closer look. But in general, it's going to really depend highly on what your material is and print technology to give you a more clear answer on that.
Okay. A question is, if we already have a post-process machine, can we get connected on it when it is released?
Yeah, absolutely. So that's the beauty of software. So all of our solutions out in the field today will be field upgradable when Connected is commercially available.
Okay, we'll give it another minute here for more questions. Okay, so when the file type is uploaded, how is it directing which parameters to run the part at?
I'm sorry, when the final what is uploaded?
When the file type is uploaded.
So it depends again on the print technology and what's in the actual file itself. But it's assessing the geometry, and it's of course taking into account the material. It's trying to identify where there are very thin wall parts, is there complex internal channels. So it's assessing those features at a basic level to understand what some challenges we might run into. And then of course translating into those into our post-print solutions, meaning you may have to lower the temperature if it's very thin wall, reduce agitation levels, and so forth.
Okay, we'll wait for any more questions for another minute before we wrap up. Okay, I think that's all we have today. If you had any further questions, please feel free to reach out to us after this event. Thanks so much, Andy and Nick. We hope to see everyone at more Unlock Live AM events this week, and we hope you all have a great day.
Thank you.